Good morning. My name is Sudhakar. So I'm teaching basic manufacturing technology. Right. In that we have finished lathe and broaching machines. Right. So now we have finished the 2 units, the lathe machine and broaching. So in the last class we have finished broaching. Right. In that broaching we have discussed about the what is broaching and what is the broach tool and operations of the broaching, right? Types of operations, and after that we are going to the broaching missions, right? After that we have discussed about the advantages and limitations of the broaching mission. So these are the topics we have covered in the last session, right? So broaching means removal of material by using some special tool called broach, right? This broach tool is having number of teeth, 3 teeth, right? Rough teeth, semi-finished teeth, and finished teeth. And broaching, push broaching and pull broaching are general types of broaching operations. Okay, broaching machines. Generally, horizontal broaching machines or vertical broaching machines, and the second one is the rotary table machines, right? So these are the basic types of broaching machines are available. Okay, so these are all covered in the last session, right? And the lathe machine also we have completed so far. Now, and we have we done some discussions on broaching and lathe machine also in the last sessions, right? So far that we have discussed in the earlier sessions. Now we are started with another chapter, that is shaper, slaughter, and planer. Shaper, slaughter, and planer. So these are the three machines we are going to discussing. In that shaper, first of all, we have discussing about the shaper. After that, we are going to planer and slaughter, right? So now today we are starting with some of the topics, that shaping machine, working principle of shaping machine, classification of shapers. Okay? So shaping machine. So this is also one type of machine used to remove the material from the workpiece in the form of amount of shapes. Okay. So that working principle, how it can be worked by doing the machining operation, and the classification of shapers. Types of shapers. What are the types of shapers we have? Um, we are observing our shaping machine. But we have learned now this session. So this is the shaping machine, the photograph of the shaping machine. Shaping machine is also called as a shaper. So we can call it as a shaping machine is shaper. Every time we are called it as a shaper, not a shaping machine. Okay. In the simpler terms, we can call it as a shaper. So we have observed so many number of parts on the shaping machine or shaper that we have discussed the details in the coming sessions, right? So that's just now, we have to observe this shaper, what are the parts it has consists. Okay? So observe in this animation, a simple the working principle we have observed. So here we can easily tell that the workpiece is fixed in a fixture and it is not moving, right? Tightly permanently fixed, and the cutting tool which is fixed in the tool holder, right? That is reciprocated. In the simple way, we can understood that here the chip is removing in the forward stroke. The return stroke is ideal. As we have learned in the broaching machine, the forward stroke or cutting stroke is going to move slowly, and the return stroke is return fast, right? Here also we have observed that uh, the cutting stroke is going slowly, and the return stroke is backward stroke is very fastly return, right? So that is the not topic here. Here we have to observe the working principle. So the workpiece is fixed and the cutting tool reciprocates on the workpiece. So amount of material is removed in the form of chips, right? It is observed in the animation. So a shaper is a machine. The general statement is it produces the flat surfaces. Shaper is a machine which produces flat surfaces. Generally, the lathe machines are, we can tell that if we want to produce the cylindrical surfaces, we are going to the lathe machine that we have learned in our previous chapters. Here, so you can tell that a shaper is a machine which produces flat surfaces. A shaper is a machine which produces flat surfaces, right? A ram holds the tool which reciprocates. The ram holds the tool. Here, this is the ram which is reciprocated on the workpiece. That is called ram. In that ram, we have fixed the tool. We have fixed the tool. So a ram holds the tool which reciprocates. The ram holds the tool which reciprocates. Work is fed perpendicular to the tool. Work is fed perpendicular to the tool. A ram holds the tool which reciprocates, and the work is fed perpendicular to the tool. So observe here, here the workpiece and the cutting tool is here. So both are in 90 degrees. Both are in 90 degrees. So here the ram holds the cutting tool and which reciprocates on the workpiece, and here the workpiece is fed perpendicular to the cutting tool. Right? These points I have observed in this diagram. And here the working principle explained in simple way. The cutting tool moved on the workpiece at the line A to B repeated. If we want to do the operation, the cutting tool has to be moved in the AB direction repeatedly. So then only we can remove the amount of chips whatever we require. Okay. Now here also large quantity of material is removed from the workpiece. Whereas in broaching, small amount of material removed, but here the large quantity has to be removed by the shaping machine. That's why the cutting tool is moved on the workpiece in A to B line repeatedly. A to B line repeatedly. So we have observed that the cutting tool here and the workpiece is fed perpendicular. Workpiece is fitting like this. So the action is taking place like this. Here repeatedly action is done, and after that it's going to the next line. So here next line is happening here. So the workpiece is fed is against the cutting tool is in this direction. The workpiece is fed to the cutting tool against in this direction. That's why we can in the last point we have told that the work tool is the workpiece is fed against the tool is perpendicular. Is perpendicularly fed to the cutting tool, right? So the cutting tool is repeatedly moved on the AB direction, right? So where the amount of required is removed, it moves to the another area, right? So here the cutting tool repeatedly travels along line AB. The cutting tool repeatedly travels along line AB, and the work is fed a small distance each time. The workpiece is fed a small distance each time. Here, the workpiece is fed a small distance means here the manufacturing process has been taken place. Now we have to move here, this place. So that's why it is moving a less distance, a small distance. So it is fed a small distance. So the workpiece is fed a small distance each time, and but the cutting tool is moved repeatedly on this motion, right? Cutting tool is repeatedly moving on this motion. No? So cutting tool repeatedly travels along line AB, work is fed a small distance each time. Feed of work and line of tool motion are in same plane but perpendicular. So feed of work, this is the feeding of work, and this is the line of tool. Motion are in same plane. So they are often happening on same plane. Feeding and tooling, tool, line of tool. Feed of work and line of tool motion are in same plane, but both are acting perpendicularly. Both are acting perpendicularly. So after doing that A to B motion, so here the workpiece is moving from here to here. Here the work is start A to B. So uh, feed fed workpiece is fed in this, the cutting tool is fed in this direction, right? So doing this all lines, the end line is CD. So the tool line eventually reaches the position CD by doing all these slots, by doing all this manufacturing. So combination of two movements results in the flat plane ABCD being machined. So here the entire plane has been machined by using this principle. So the workpiece is fed like this and the cutting tool moving in this direction. So both are in perpendicular direction. After doing so, we are getting ABCD plane is a flat plane. Combination of two moments results in the flat plane ABCD being machined. After doing that, we are getting ABCD is a flat plane that can be we have observed. And after that, we have classification of shapers. Two types of shapers, three types of shapers, basic types: horizontal shaper, vertical shaper, traveling head shaper. Horizontal shaper, vertical shaper, traveling head shaper. In horizontal shaper, ram holding the cutting tool and it moves in horizontal plane that we have observed in our in the animation. Ram holding the cutting tool and the cutting tool moves in a horizontal plane. In the same way, we can tell that vertical shaper, the cutting tool moves in a vertical plane. The cutting tool moves in a vertical plane that we have observed in coming diagrams. So here the ram is moving in the vertical direction, and the traveling head shaper, cutting tool reciprocates and moves crosswise simultaneously. Cutting tool reciprocates and moves crosswise simultaneously. So it is called as a traveling head shaper. So horizontal shaper, ram holding the cutting tool moves in horizontal plane. Vertical shaper, the cutting tool moves in vertical plane. Traveling head shaper, cutting tool reciprocates. Here the cutting tool also reciprocates and moves crosswise simultaneously. Crosswise simultaneously. So here the cutting tool workpiece is not moved, only cutting tool reciprocates and it can be moved crosswise simultaneously. So these are the classification of shapers that we have observed: horizontal shaper, vertical shaper, and the traveling head shaper. So in this diagram, in this chart, horizontal shapers are three types: classification of horizontal shapers. One, according to the cutting action of stroke is one of the type. And two, according to the table design. According to the table design is another type, and according to the driving mechanism. So these three shapers have been divided. One is according to the cutting action of stroke, and according to the table design, and according to the driving mechanism. So, based on these three types, the horizontal shapers are in three shapes. according to cutting action stroke. Again, we can tell that push type shaper, draw type shaper. Second, according to the table design, standard shaper, universal shaper. According to the driving, gear type, crank type, hydraulic shaper. Right? So in that again, horizontal shapers are three types. In that three types, one subdivision is also there. According to action stroke, stroke of action, push type shaper is there and a draw type shaper. According to the table design, standard shaper, universal shaper. According to the driving mechanism, crank type, gear type, and hydraulic shaper. Crank type, gear type, and hydraulic shaper. In push type shaper, similar to the push type broaching operation, metal is removed when the ram moves away from the column. In the forward direction, the metal removal has been taking place. So the most common used in practice is the push type shaper. So in the animation we have observed that the push type shaper, here the metal is removed when the ram moves away from the column. So this is the most common type of shaper machine used in practice. Unless otherwise specified, the term shaper refers to push type shaper. So generally, the shapers are called push type shaper because here we are using push type shapers. So the metal removal is taking place when the ram moves away from the column. So these are the most common type of shaper machines used in practice. The draw type shaper, this is nothing but a draw type shaper is nothing but a pulled shaper because here the metal is removed when the tool is drawn towards the column. Metal is removed when the tool is drawn towards the column. So that means pulled. So the return stroke, the metal removal has been taking place. So we can call it as a pull type shaper or we can tell that it is a draw type shaper and it allows heavier cuts to be made. If we want to do the heavier cuts, we are going to the pull type shaper and less vibrations during cutting. By doing the cutting operations, less vibrations are produced. And standard shaper. So work table can be moved vertically or horizontally. In the standard shaper, work table can be moved vertically or horizontally. These are called standard shaper. And universal shaper, vertical table can be moved horizontally, vertically, swiveled, tilted. This is the most commonly used in toolbox. So in the universal shape, the table, the workpiece which is hold on the table can move horizontal motion, vertical motion, swiveled, tilted. This is the most. So based on this, always the cutting tool is fixed in the ram. The ram has only the uh, reciprocating motion. If any has to be changed, that will be made on the workpiece only. So that's why the table has to be moved in all the directions. In that universal shaper, we can call it as universal shaper. That universal shaper is having the table can be moved horizontally, vertically, swiveled, tilted, right? So these are the four motions, motions of the consist of the table that is called universal shape, right? And crank type shaper, driving mechanism is by crank and gear. We know that the crank and gear mechanism, right? So here the reciprocating motion is converted into a rotary motion. In that crank is having a rotary motion and it is converted into reciprocating motion, right? So that type of shapers also we have observed. And gear type shaper, here the driven by rack and pinion mechanism. Here the motion also done by the rack and pinion mechanism. Hydraulic shaper, here it is driven by pressurized oil developed by a pump which is run by an electric motor. Okay. So these are the shapers we have observed in the in this class, hydraulic shaper. It is driven by oil pressure developed by a pump which is run by an electric motor. So driving mechanism is by crank and gear, that is crank type shaper. Gate type shaper is having driven by rack and pinion mechanism. Right? So by this we can conclude it now a shaper, its working principle and the classification of shapers that we have learned now. Now we are moving to another topic. Before going to discuss the another topic, we have to do some quiz questions. That a horizontal machine that produces flat surfaces is lathe, drilling machine, shaper, sawing machine, that is shaper. Part of shaper which reciprocates holding the tool is table, ram, rise. Ram in shaper worked against tool is perpendicular. Okay, so in this we have observed that what is shaper and classification of shapers and its working principle. Its working principle generally tell that the ram reciprocates, the reciprocating tool reciprocates on the workpiece which is fed perpendicular to the cutting tool. So the material removal taking place in the forward direction, in the backward direction, it is in ideal state. So we can tell that this is the working principle of shaper. Okay. Most commonly used shaper machines are push type machines because the material removal has been taking place in forward direction. The return stroke it is in ideal, right? So now we are moving to another. Now we are moving to another topic that is construction of shaper. The construction of shaper, the function of each part, and specification of shape. That have to be discussed, shaping machine working, and we have observed that reciprocating machine in the previous PPT, and in that we have observed that animation also. We have observed the reciprocating motion, but how that reciprocation in motion is getting from other mechanism that has been observed in this in this animation. Right here one link is there. So this link is rotated on the some device. Okay. So this rotary motion is converted here reciprocating motion. Understood? Here the rotary motion of this slotted lever here oscillate. Here the oscillation, this one is oscillation. Okay, this oscillation is occurred because of the rotary motion of this device. So this rotary motion gives the oscillation to this lever, and this oscillation here converted into reciprocating motion. So we are getting the to and front motion of the ram. So with that ram, the cutting tool is also moved. Here again we have observed the material removal taking place in forward stroke. That means the material removal taking place away from the column. The cutting tool moving away from the column. In that direction, we are removing the material in the form of chips. So these are the shaping machine parts. In this every part we have observed that this is the table. On this table, a vice is there. So one is fixed chart and another one is the mobile chart. So in that vice we have fixed the work pieces. Okay, and here adjustable sliding support. So based on the height adjustment of this workpiece, height adjustment, we can use this adjustable sliding support, so it can be moved up and down. Here, the cross traverse handle operating this lever, it can be moved in this direction. The table can be moved in this direction. So that this is cross traverse handle, and here the wise we have already discussed, and this is a post, single tool post. So here we have fixed one tool at a time. Okay, one tool at a time, and the nesting operation has been taking place. And this is the clapper box, which is used to hold the tool post. So the clapper box to hold the tool post, and come to here tool feed handle. So by using this, we can fix this tool in the tool post, right? Like loosening and tightening the tool post, and then come to here graduated collar. Here the graduated collar is there, and the ram clamping unit, ram clamping nut. So we can using this tightening and loosening. By this, we can get this motion, motion, and the scale indicator and the clutch handle. So these are the shaping machine parts we have observed in the diagram. Table wise post, clapper box, tool feed handle, graduated collar and clamping nut, scale indicator, clutch handle, adjustable sliding support, cross traverse handle. So based on this, we have discussed these main parts: base, column, ramp, tool post, table, crossrail. Okay. So the main parts of this shaping machine are: one is base, two crossrail, and third column, four saddle, five ramp, six tool head, seven table, and eight is clapper box. So these are the main parts we have observed in the shaper machine. Okay, that has to be discussed in detail now. Total 8 parts. In that 8 part, we have to discuss one by one on the parts. Yes. So this is the constructional details of shaper. Already we have observed in the diagram. So once again, we can see this is the base. Okay, and the base is used to support all the elements, as we have observed in all the machine weight and loads. And table here, the table is used to holding the rise, and that rise we have fixed the piece. And here the column, which is hold some mechanisms. The column is housing the mechanisms and the lubrication oil. Right on the above the column, ram is fixed to that ram. The tool post, the tool head is fixed to that tool head. The tool post is fixed. Here the cross rail, based on the work adjustment, we can use this cross rail, right? So all of the other things we have observed in the previous diagram. Now we have to discuss every parts in detail. So the base is nothing but it is the bottommost part of the shaper we have observed, and it supports all other parts of the machine, and it acts as a reservoir of the lubricating oil. And the base, all the machines bases are made with the cast iron because it has to be robust in construction. So that's why we are using the cast iron material. So the most part, I suppose, other parts of the machine, and it acts as a reservoir of lubricating oil, and it is made up of cast iron. Column, it is vertically mounted on the base, and it houses driving mechanisms of ram that we have discussed already, and we have observed also the ram. The one of the slaughter lever oscillates in the column. So that is how that houses in the driving mechanism of RAM, and it has guideways on which RAM slides. The column on the top of is having guideways. On that guideways, the RAM is moving, right? The RAM is slides, so it is made of cast iron. So the RAM is made of cast iron. The column vertically mounted on the base houses driving mechanism of RAM, has guideways on which RAM slides, and it made of cast iron. So these are the uh, points of the column. And RAM, the main moving part of the shaper, is called RAM. It carries tool head and connected to the driving mechanism. Understood? So the main moving part of the shaper is the RAM that we have observed in the diagram. It carries a tool head and connected to the driving mechanism. Now, shaper. Shaper and a table. A table is a box like a casting with T slots on its top. Because slots, we have fixed the jars, right? Vices. On the vices, in the vices, we have fixed the work pieces. So that's why it is having T slots. The table, it is a box like the casting with the T slots on its top, and the shaper wise fitted in the T slots, and within the wise, the work is fit in the wise. So the wise may be the wise having two jars, one is fixed jar and another one is open jar. Okay, cross rail used to move the table up and down, because to adjust the workpiece height we need the cross rail movement. So use it to move the table up and down. The upward movement is controlled by an elevating screw, and the side movement is controlled by lead screw. Just to the cross slide movement is using to adjust the table. So it is having two motions, one is upward movement and another one is side movement. The upward movement is controlled by an elevating screw, and the side movement is controlled by lead screw. So these are the cross rails used to move the table up and down. So we are having these mechanisms also. Saddle. It is mounted on cross rail, saddle mounted on a cross rail. It supports the table, moves across the cross rail left to right, moves movement obtained by a cross feed screw. So it is mounted on a cross rail, saddle is mounted on a cross rail, and it is used to support the table, and it moves across the cross rail left to right, and that movement obtained by a cross feed screw. And the tool head, tool post. Tool head is attached to the front end of the ram, and carrier clapper box and tool post on it, and it can be swiveled at any angle on either side. So here it is attached to the front end of the ram, carrier clapper box and tool post on it. Okay, carrier clapper box and tool post on it, and it can be swiveled at any angle on either side. So the carrier clapper box can be swiveled any other side. Okay. Clapper box, it is hinged to the tool head. It houses clapper block, swings outward in return stroke. Tool post mounted on a clapper block. Okay. The clapper box, it is hinged to the tool head. It houses clapper block, swings outward in turn stroke. In return stroke, tool post mounted and clapper block. And coming to the specifications of shaping machine, maximum length of stroke of ram that have to be observed, and the type of drive, power input, floor space required, weight of the machine, cutting to return stroke ratio, and feed. So these are the points have to be considered, and going to decide which of the machine we need. Okay. So first we have to do the maximum length of the stroke of the RAM and the type of drive, power input, floor space required, weight of the machine, cutting tool, gun stroke ratio, and feed. Okay. So these are the constructional details of the shaping machine and the specification of. Now we are moving to the shaper driving mechanisms. In that shaper driving mechanisms, we have discussed. We are going to discussing about the Whitworth quick return mechanism. Okay. So first of all, what is shaper driving mechanism has to be known, and after that we are going to be discussing Whitworth quick return motion mechanism. Okay. So we have observed in the driving mechanism that RAM is having reciprocating motion, right? So to get that motion, we need, but the driving mechanism, we are getting the rotary motion of the motor, electric motor or hydraulic motor. We are getting the rotary motion, but that has to be converted into reciprocating motion. So for that we need some mechanisms. So what is that? We have to observe now. The shaper driving mechanism is changes rotary motion of power source electric motor to reciprocating motion of RAM. That has been we have discussed now. We are learned that the shaper driving mechanism changes rotary motion of power source. That is electric motor power source to reciprocating motion of the RAM, and the material is removed during the forward stroke of the RAM. The return stroke of the RAM does not no cutting, hence it is called ideal stroke. The RAM which cutting tool has to move slowly in cutting stroke. Okay, so these points has been covered in our coaching mission also. The material removal is taking place in the forward stroke. That forward stroke is also called as a cutting stroke, and in the return stroke we are not removing any material from the workpiece. So that's why the return stroke of the RAM does not have any cutting. Hence, that stroke is called ideal stroke. Okay. So the RAM with the cutting tool has to move slowly in cutting stroke. So to reduce the tool damage, tool defects, or to reduce the workpiece defects, we have to move the cutting tool in forward direction slowly, because there is a contact between the cutting tool and workpieces happen. So there may be chance to get the uh, tool may be damaged and the workpiece may be damaged if the tool is moving very rapidly. So that's why we are allowing the cutting tool to move slowly in the forward stroke, or that can be called as a cutting stroke. But in the return stroke, it has to move rapidly because it is an ideal stroke. So we have to reduce the production time. We are arranging that return stroke is very fast. So because it is an ideal stroke, so there is no metal removal has been taking place. So that's why to increase the production time, since return stroke does no cutting action, the RAM should move faster during the return stroke. The shaper driving system incorporates quick return, so that means it is called as a quick return mechanism, so that the RAM moves faster during return stroke. So to get this return stroke very fast, the shaper driving system incorporates quick return mechanism so that the RAM moves faster during return stroke, thus minimizing the ideal time. So in the animation, we have observed that the forward stroke is moving very slowly compared to the return stroke. So compared to the return stroke. So that quick return mechanism is a slotted lever mechanism that is observed in the diagram. Here we are observing in this diagram the lever has having a slots. In that slots it is moving like this. So return stroke is getting by the application of the some mechanisms. Okay. shaper driving mechanisms are Whitworth quick return mechanism, slotted link with quick return mechanism, hydraulic quick return mechanism. Okay, in this diagram we are observing that it is a slotted lever mechanism because it is a lever and it is having a slots. So the slotted link quick return mechanism has been observed, and Whitworth return mechanism, hydraulic quick return mechanism. Okay, so in the diagram we have observed that the Whitworth quick return mechanism. Right here, the rotary motion is been converted into reciprocating motion of the ram. Rotary motion from the motor is converted into the reciprocating motion of the ram. Right, and here also observe that the stroke and the length of the stroke observed here. Here, from up to here, it is a small arc distance. Okay, small arc distance, and it is a large arc distance. It's the large arc distance. So large arc distance produces the forward stroke. Understood? That's a large arc distance. Here, links are there, fixed links. Okay, the cutting tool here. Okay, it is the stroke length from here to here to feed the workpiece. So from the motion of a cutting tool, this mechanism, this link is from here to here is having large arc distance. So in that link mechanism, it is moving in slow direction towards the workpiece. So it is we can call it as a cutting stroke. From here to here, it is having a small arc distance. So this link is going to from here to here in the small arc distance. So that's why it is quickly returned to its quickly returns to its original position. So that's why we are arranging here the small arc distance and the large arc distance. The large arc distance gives the cutting stroke that has been taking place slowly, and the small arc distance or return stroke that can be done by fastly because it has an ideal stroke. So observe this diagram. Observe this diagram. So there is the parts we have to observe. Mechanism A, B, C, okay, E, A, B, C, D, E, right? So while doing the motion, crank BC revolves. Crank BC revolves. It revolves at a uniform speed. During cutting stroke, point C travels from Y to X through Z. Y to X through Z. Okay. Point C here, it travels from Y to X through Z. So it is a large arc distance. So this large arc distance gives the cutting stroke. Then time for cutting, so ram returns at high speed as the crank rotates from X to Y through T. So then time for cutting stroke 360 minus 5, time for return stroke by 5. Since 5 is smaller than 360 minus 5, the time for cutting is more than the ideal time. So for this we can tell that the time for cutting is more than the ideal time. Here crank BC revolves at a uniform speed. During cutting stroke, point C travels from Y to X through Z. Ram returns at high speed as the crank rotates from X to Y through T. Okay. Here we can easily observe that. So here the C is moving from Y to X through Z. So this is the forward stroke, that is cutting stroke. Here from X to Y, it can be covered small arc distance. It can cover small arc distance. So it is the return stroke. That can be easily, we can tell that. One, on entering the cut, the highest pressure on the tool and the slowest speed is available. So in the cutting stroke, what we have observed that we are getting the highest pressure and the lowest speed. So the maximum pressure is holding the ram down is it as it slides. Okay. So the maximum pressure is holding the ram down as it slides. So this is the Whitworth quick return mechanism. In a simple way, I will tell you that. So here A, B, C, D, A. These are the links A, B, A and B and C, D, E. These are all the links. Here, the movement is the C, which is moving from Y to X through Z is the forward stroke. In this stroke, we are getting the pressure is high and slow speed is low, and the C moving from X to Y through T. Here we are getting this slow high speed because it is a return stroke or ideal stroke. So in this way we are getting the forward stroke and return strokes are in the forward stroke it is very slow and return stroke it is very high. So we have observed so far in today's session what is shaper, what are its constructional feature, what are the types of shapers and the working principle of shapers, okay, and what are the driving mechanism, holds the shaper and constructional details of the shaping mechanisms, okay. The number of mechanisms employed to get QRM in shaper is 3. Metal cutting is carried out during forward stroke, okay. So by this, I am concluded today's session. Right. Tomorrow we will go to discussing about some the new things. Right. Thanking you. I am closing today and closing today's session.